massive enough to compensate for its spiral motion. They're all going way too fast, every single one. And it's not the black holes in the middle. We can mask those too and take them out of the equation. There's still a lot of stuff in these galaxies that we can't see, right? The shape of the galaxies actually implies that there's kind of a halo of dark matter associated with all galaxies. In fact, this is one of the fundamental questions: is why galaxies and why not something else, right? And the answer to that might lie in this dark stuff that we can't see. Okay. Whoa. So now the question is, where's all the matter, and why does it matter? No, just kidding. That's another matter. We need Casey here. We can. I'm going to hit the right arrow here. So where's all the matter? There's two possibilities, right? You know, so we've already passed this possibility. One possibility is that if we look at the mass of the stars appears to be what's there, and the other possibility is that there's not nearly enough mass that we can see. And we've already there's stuff we don't see, right? Okay. The universe could be slowing down, but it's not. It's actually now speeding up. So there's something else going on, right? And then it's like, okay, what's going on? Where's all the matter? Well, there's two possibilities, okay? There are two candidates for the dark matter, and one of them is massive compact halo objects, right? This is normal. This would be the best case scenario, is that as we look at machos, yes, there we go. This is like, somebody's got a sense of humor, right? Okay. I did not make that up. This is, really bored cosmologists making up funny acronyms. There's an acronym for that too. But anyway.
Why do they make the MMA?
They want macho, right? Okay. So a macho is ordinary stuff, baryonic matter. Baryons are things like protons and neutrons. Those are baryons. This is ordinary stuff. A neutron star would be baryonic matter. Okay. A star cinder, a red dwarf, an asteroid, okay? So star remnants, star cinders, all these things, right, would be candidates for this. And the question is, do galaxies have a whole bunch of these star cinders in them? And is that enough to compensate? So is only 1/10 of the stuff actually glowing, and the rest of it either didn't form stars that could radiate, they didn't have enough mass, or they already burned up and are star cinders, neutron stars, black holes, stuff like that, right? Okay. So how do you look for these? This is a real problem. If you look at the Andromeda Galaxy, you can see the stuff that's got its headlights on, but you can't see the stuff without the lights. Yeah? So how do you see these things? Well, and the answer is, it's the same way I look for pedestrians on Barber Boulevard, right? If you go from Tigard, it's Pacific Highway. You go into Portland, it's Barber Boulevard. There's a dark stretch. You go across a bridge, dark stretch around, then there's a big stoplight there. In that dark stretch, people walk across the road because they get off the bus on this side, and there's many apartments on this side, right? They walk across that road, and there's no crosswalks. They're taking their life into their hands. Here's the only way to see them, because they all wear dark clothing. It's like an African community, and some of them are wearing, like, honest to God, head to foot hoods, right? Hijab or whatever that is, right? Okay, they're wearing this dark clothing, walking across the road. Here's how you see them. They walk in front of headlights. There's always oncoming headlights, and you just look at those headlights, and if one of the headlights blinks on and off, somebody walked in front of the headlights. And it's like, oh crap, and you slow down, and you're like, where's that person? Oh, there they are. It's almost impossible to see a person wearing all black walking across a road when there's like oncoming headlights, except for when they block the headlights, right? So if Andromeda has tons of these massive compact halo objects in it, then the Milky Way should as well. And we should see them, the local Milky Way ones, by looking at stars. If we just look at thousands and thousands of stars, right? And even this is too mundane work for graduate students. So what they did was they got computers and little fiber optic things, right? And they actually made these things that stared incessantly day in, day out. Well, okay, just at night, right? Okay, at these stars every night, all night long, staring at the same stars, because we're looking for something going in front of the star. This is called a microlensing survey. And so basically, it's not likely that it'll actually pass right in front of the star, but it will distort space and make the star waver, just like if you're bending a lens or something like that. You'll make the light through it sort of flicker, right? Okay, so it turns out that we discovered some massive compact halo objects, but not nearly enough. There's just really not very many of these. Okay, and so the funny thing is that this whole project that they spent all this money on actually discovered something like there's 17 types of variable stars no one had ever found. If you look at the intensity of a star, day in and day out, night after night after night after night, okay, you can actually see, and some of them fluctuate. There's a lot of variable stars, a lot of different types. They never knew that. That's funny, isn't that funny?
Yeah.
There you go. So it wasn't a total waste of time, but they didn't find the matter they needed. Okay, they found like 1% or something like that, not nearly enough. We're looking for 90%, right? So what's the other thing? Well, weakly interacting massive particles. Got to have mass. There you go. Machos or wimps. I'm a wimp, man, myself. Always was. I wanted you to know. Some people went off for the macho thing. I'm definitely a wimp. No, I mean, no, but I mean, right? Now, here's the problem. We don't think it's neutrinos. Neutrinos have mass, but it's not neutrinos. It's something else. Something we haven't discovered yet. And this is a little bit embarrassing because it's most of what's there. So it's a little bit like the golden compass, right? There's all these other universes, and they're right there, but we don't know how to see them. Yeah, we need that knife. And somebody was saying, Jason Wang was saying that there was they actually had some laser that was going to cut through space itself or something like that, which is somewhat larger than the subtle knife. Okay, but there we have it, right? Okay, so this is it. We don't know what it is. I'm very sorry. It's not baryonic. They don't think it's baryonic. I don't know why they don't think it's baryonic, like normal matter. Probably because of the creation scenarios. But there it is. You will get a Nobel Prize. There's one with your name on it right now. Okay, if you get that, if you figure this all out, right? And they're going to figure it out pretty soon, right? But yeah, that's right. Tomorrow they figure it out. Like, damn, I didn't get my.
But I was signed up for the telescope.
Yeah, I know. Well, okay, so really you need really long-range stuff. You need telescopes. It's not enough to just look at occasional type 1a supernovas. You need a neutrino telescope to figure this out, right? And of course the devil is that the very thing that makes neutrinos so valuable, the fact that they don't interact with matter and can travel through dust, through galaxies, through stars, through everything, right, makes them valuable. But it's like you can't detect them because you can't detect them, right? You know what I'm saying? They don't interact with matter. It's like the guy that there's two jokes, right? Okay. The guy's walking down the street with bananas in his ears, right? Yeah. And two guys are walking behind him, and the one guy goes, "Geez, why does he have bananas in his ears?" And the guy says, "Well, why don't you just ask him?" So he taps him on the shoulder. He says, "Why do you have bananas in your ears?" And the guy says, "I can't hear you because I've got bananas in my ears."
Classic.
My sister-in-law thinks that's a really funny joke. I still don't get it, but I just tell it. And some kids laugh. It's like the genetic test. Like some people can taste that bitter stuff, right? Some people can taste the bitter stuff, and some people can't taste the bitter stuff. Can't remember which one I am, right? Okay? And if I tell that joke, I look around the class, and there's not very many, but there's some people who are just like, "Yeah, it's funny," right? Some people are like, "It's not funny," Okay? There you go. I think Casey did laugh at that one. It might have been a reflexive laugh, but one more seat forward. That's good. It's a little too cackly. Yeah. Okay. So, yeah. Okay. Right arrow. Paradoxes. This is the fun stuff. The Big Bang couldn't have happened because of this. Yeah. Oh, the lightest supersymmetry particle. Right? Nobody thinks. And we don't know. String theory, supersymmetry the same as string theory? I can't remember. But it's the lightest supersymmetry theory. It would be that particle, but we don't know. We don't think it's a mundane thing like that. It might be that particle. We don't know, right? So there it is. Here's this thing you don't know what it is, and it's not that. Okay. So here are the paradoxes. This is like people say, well, the Big Bang couldn't have happened because, and the first one is that there could be no effect without a cause, right? Nothing caused the Big Bang, so therefore it couldn't have happened. And the answer to this is that, no, that's just not true. In quantum mechanics, there are things like the decay of an atom, a radioactive decay of a nucleus, right? There's no reason for it. It just happens. It's existence itself is